So in this problem, we have a drawing showing two strings that have the same length and linear density. The left end of each string is attached to a wall, while the right end passes over this pulley here and is connected to objects of different weights. We have WA in this figure and WB hanging to the string in the second figure. Different standing waves are set up on each string, but their frequencies are the same. So we have the same frequency so far, the same length, and the same linear density of these strings as well. If WA is equal to 44 newtons, what is the value of WB? So we want to find the weight, the value of the weight that is hanging from the string in the second situation. So first of all, we can start by thinking of a formula that can link this weight to what we are given here, which are standing waves. These are standing waves on a string with fixed ends, so we know that the frequency will have the form of NV over 2L. Now, in order to link this to the weight, let's remember that the speed of a sound wave on a stretched string is equal to the tension on this string divided by mu, which is the linear density of the string. The value of the tension here is going to be equal to the weight itself due to the principle of equilibrium. Because if we look at the objects we have here, the forces acting on them are the weight itself and the tension that is exerted by the string. So by the principle of equilibrium, we know that the tension will be equal to the weight. Now, if we plug this into the equation of the frequency, we're going to have this equation. Now, we know that the two standing waves have the same frequency. So we can start with this equation that states that the frequency on the first string is equal to the frequency on the second, which gives us that NA over 2L radical WA over mu will be equal to NB over 2L. Note that the length of the two strings is the same, WB over mu. So if we simplify this first of all, we will end up with NA radical WA equals NB radical WB. Now we're looking for WB, the weight that is hanging from the string in the second situation. So if we rearrange, this is the equation that we will get. All we have to do is substitute n. As we can see in this situation, NA is equal to 1, while here NB is equal to 2. So this will give us 1 over 4 WA, which is basically 44 newtons over 4, and this will give us a value of 11 newtons for the weight that is hanging from the string in the second figure.